Welcome back to my YouTube channel. Today we will discuss Cauchy completeness of real numbers. Okay, the Cauchy completeness of real number is say that any given real sequence. Okay, this is Cauchy if and only if it is convergence. Okay, first we prove sufficient part of these theorems. Okay, that is given any convergence sequence, we show that this is a Cauchy. Okay, now let's start the proof. Let xn is convergent. Okay, so suppose xn is converges to n. Okay, by definition of convergence, any epsilon greater than 0, there exists a natural number n such that for all n greater than equal to n, we have mod of xn minus n less than epsilon. Okay, so and also mod of xm less than mod of xm minus n less than also epsilon, that is epsilon by 2 and it is epsilon by 2. Okay, here also m greater than equal to n. This is trivial for the definitions of the convergence of this sequence. Okay, my intention to show mod of xn minus m also less than epsilon. Okay, now mod of xn minus xm. Okay, this equal to mod of xn minus l plus l minus xm. Okay, by the triangle inequality, that is less than equal to mod of xn minus l modulus value plus mod of xm minus l. Okay, so from here this is less than epsilon by 2 plus epsilon by 2, this is equal to epsilon. Okay, so therefore mod of xn minus xm modulus value is less than epsilon for all n comma m get equal to n. This is definitions of the Cauchy sequence. So this implies the sequence xn is Cauchy. Okay, so complete the sufficient part. The sufficient proof of the sufficient part is complete, but now proof of the necessary part. First of all choose this sequence is Cauchy. We show that xn is a convergent sequence. Okay, so let xn is Cauchy. Okay, Cauchy sequence. By the definitions of the Cauchy sequence, any epsilon greater than 0, there exists a natural number such that for all n comma m greater than equal to n, we have mod of xn minus xm less than epsilon. Okay, we choose epsilon equal to 1. Okay, so that is mod of xn minus xm less than 1. Okay, no problem here because epsilon is any arbitrary point. So now mod of xn This is also written as mod of xn minus xn plus mod plus xn. Okay, modulus. By again triangle inequality, we have less than equal to mod of xn minus xn plus mod of xn. Okay. So from here, we written as less than 1 plus mod of xn. Okay. For all n greater than equal to n. Okay. Now we can choose m equal to supremum of mod of x1 comma mod of x2 comma dot 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 mod of xn and 1 plus mod of xn. So we have mod of xn less than equal to m for all n belongs to natural numbers. Okay. Why did I choose m like this? M like this? Because for those natural numbers who is greater than n, the quantity of this mod of xn is less than 1 plus mod of xn. This is hold, it is true. Okay, fine. But when those of natural numbers which less than n, there is no guarantee this less than inequality is remaining same. Okay. Because here the value of mod of x1, mod of x2, mod of xn each greater than 1 plus mod of xn. Okay, it is also possible. So we choose m in this way. The value of mod of xn is always less than equal to m for all any natural number. Okay. Okay. So now this line implies the sequence xn is bounded. Okay. This is a bounded sequence xn and also xn is real number sequence. Real sequence. Okay. By the Bolzano theorem, xn has a convergence subsequence. Okay. So by Bolzano Weierstrass theorems, xn has a convergence subsequence, say xnk. Okay, and this subsequence is convergence. Suppose xnk converges to n. Okay, by definition of convergence, any epsilon greater than 0 there exists a natural number n belongs to n such that for all nk greater than equal to n, we have mod of x nk minus l less than epsilon. Okay, that is epsilon by 2. Okay, for simplicity of the calculation. Now mod of xn minus l. Okay, This is also written as mod of xn minus xnk plus xnk minus n. Okay. So by again triangle inequality, we have this is less than equal to mod of xn minus xnk modulus value plus mod of xnk minus n. Okay. Okay. So this value and this value, this is from, suppose the equation number, this is called equation number 3. Okay. And this also we choose epsilon by 2 by simplicity of the calculation. Okay. And this equation number 4, sorry, is 4. So from equation number 3 and equation number 4, this quantity and this quantity is strictly less than epsilon by 2 plus epsilon by 2. Okay. When here suppose this is n1, okay, and suppose here this is n2. This is hold when nk and n greater than max of n1 and n2. Okay, this is hold. So this is equal to epsilon. So therefore mod of xn minus n also less than epsilon for all n greater than max of n1 comma n2. Okay. So this is a definition of convergence sequence. So there, this implies xn is converges to n. So xn is a convergence sequence. Okay. So hence the proof.